Alright, time for another draftphysics.com video presentation. Debatephysics.com also, where you can see a playlist for all of these short videos. And hopefully this one will be short. Don't think we can evade it being short, frankly. It's a simple idea. So this is the 5-ton train versus the 10-ton train. We got a 1 mass, a 2 velocity. Momentum is the same for a 2 mass and a 1 velocity. Doesn't make any difference. Kinetic energy says this has twice the energy. So it says this has twice the energy if I conserve the momentum. So if I make a gear and I welded one gear onto another gear, or a flywheel, doesn't really matter, and then I turn it, okay, it's really just a lever, okay, and you're just going to throw the objects by turning it. This is going to weigh, okay, the same as the 2 mass. They're going to apply the same force against you, pushing them. You're just going to push them into gravity. The angular momentum is exactly the same. It's linear. It's just based on velocity. This velocity will be 1/2 the velocity of this one here. And frankly, and there's no fulcrum to get in your way. There's no place for the momentum to be destroyed. So for the kinetic energy theory to be viable, that is, for it not to be a free energy formula, this needs to be 1.4 the velocity somehow. Somehow it has to be harder to move this lighter object, technically, to throw it, to turn it, to put it through this motion, and there's just no rational way you can destroy the momentum to force this result to make kinetic energy conserved. So it does conserve momentum. Gears work. You could apply a gear system, and gears are efficient and they convert momentums, and that's what they do. And there's really no logic at all to people who are going to argue that it's a viable, kinetic energy theory is viable, because it's a free energy formula, frankly. You can use the same force and get twice the energy, and that doesn't make any sense, and it doesn't work that way. And I just don't see any rational way somebody can explain how this lighter object, just a little bit further out, is somehow harder to push. There's no reason it's going to be any harder to push. It's going to be exactly the same. You're not really going to be able to tell the difference between the 1 mass, twice the distance, and the 2 mass, half that distance. You're not going to tell the difference because they weigh the same. And things that weigh the same can't weigh different. So that's pretty much all the argument you need. We don't have the experiment. I can't show you a video of somebody testing this and seeing how much torque it takes to turn the gears. But frankly, all kinds of watchmakers and all kinds of people probably know what the truth is, that yeah, gears work. They conserve momentum. They don't make free energy. And kinetic energy is just not viable as a theory. Can't make any sense. So that's pretty much it. Yeah, don't need to say much more. It's a free energy theory. It really can't, it's never been well evidenced. And all they have are little niche experiments that they say happen. And I don't see how it overcomes this simple fact that there's just no logic to explain how this is harder to move when it doesn't weigh any more than this by weight. There's no force that's going to make this more, and especially since gravity's 9.8 meters per second, and the time will be exactly the same. Turning this and turning this will be exactly the same time. Alright, so half the mass, twice the speed is really the same thing as a 1 mass at a full velocity. Alright, enough said.